While sunbathing on the balcony of your third floor apartment, you notice someone drop an 8.4 kilogram pumpkin from rest from the roof of the 5-story building across the street. Since you just completed a course on surveying, you know that the two identical buildings are D equals 34 meters apart and have floors that are H equals 5.1 meters tall. Part A, determine the magnitude of the angular momentum of the pumpkin as observed by you immediately after it is dropped. This is mv cross r, but v is 0, so angular momentum is 0. Part B, determine the magnitude of the angular momentum of the pumpkin as observed by you as it passes the third floor balcony of the other building. Here we can use Ke equals Pe, solve for the velocity. 2 floors is our drop, and we get 14.14 meters per second. So in this case, it's directly across from you. R is 34 meters, theta is 90 degrees. MVR sine theta is 4,038 kilogram meters squared per second. Part C, determine the angular momentum when it goes past the second floor balcony. V is a little bit larger because now it's fallen for 3 floors. R is larger, but it's now at an angle. Instead of straight across, it's down like this. And we want the sine of that angle. We find R through the Pythagorean theorem. We find the angle is 90 minus the arctangent of 5.1 over 34. That's 81.47 degrees, but notice that r times sine theta is 34 meters. That's because if we look, r times sine theta will always be the distance between the ground floors of the two buildings, or 34 meters. Anyway, we put in what we know, and we get 49.47 kilogram meters squared per second. Part D, we go to the first floor. Now our drop is 4 floors. V is increased to 20 meters per second. R increases, but theta decreases in such a way that r sine theta is constant. We get 5712 kilogram meters squared per second. Finally, part E, determine the magnitude of the angular momentum of the pumpkin as observed by you immediately before it hits the ground. We have a full 5-floor drop, so our velocity is 22.36 meters per second. R has now gone up to 37.28 meters, but theta is down to 65.77 degrees. And again, r sine theta is 34 meters. We plug in what we know and get 6386 kilogram meters squared per second.